stem and leaf plots. So this is part of our graphing and looking at different visual displays. And we're going to start with a stem and leaf plot is a graph used to organize and display data to compare frequencies. Each leaf on the plot represents the right-hand digit in a data value, and each stem represents the remaining left-hand digits. So for example, if we have the number 25, the left side we have the 2 for the tens place, and on the right side we have the 5 for the ones place. So this would be read as the stem is on the 2 and the leaf part is the 5. So if we're given a stem and leaf plot that looks like this, and we're asked to list the data values, and let's say we're given a key where 1, 2 means 12. So the 1 is representing the tens digit and the 2 is representing the ones digit. So this would mean 1, 2 would represent 12, 1, 5 would represent 15, 4, 0 would be 40, 4, 1 would be 41, 4, 1 again would be 41, 5, 2 would be 52, 5, 7 is 57, 5, 9 is 59. So the data values we're given on this stem and leaf plot are 12, 15, 40, 41, 41, 52, 57, 59. All right, so you guys look at this stem and leaf plot, pause the video here, and list the data values from the stem and leaf plot. All right, welcome back. So these 0 parts, the 0, 6 is 6, the 0, 9 is 9, 1, 4 is 14, 1, 7, 17, 2, 2 is 22, and 2, 5 is 25. We can also have what's called a back-to-back stem and leaf, and a back-to-back stem and leaf can be used to compare 2 sets of data, and the stems would be running down the center of our graph, and we'd have one set of data that's read from left to right, and one set of data that's read from right to left. So let's see what that looks like with a back-to-back stem and leaf plot. So we have the U.S. House of Representatives for select states, and we have them in 1950, and we have in the year 2000. So we're going to make a stem and leaf plot, and all of our data have a tens place of 1, 2, 3, or 4. So we're going to run that down the middle. And 1950 we're going to list on one side, and the year 2000 we're going to list on the other. So we're going to take our data, so like 25 for 1950, the 2 will be on this side and the 5 will be here. For 14 we would do 1 and then 4 on the 1950 side, and we would continue. What about the 2000 side? On the 2000 side we're going to have our leaf parts over here. So for 19, the 1 is on the, here goes with 9, 10 would be 1, 0, 15 would be 1, 5. So our graph for the 1950 data is read, the stem from the center to the left, 14, 18, and the year 2000 data is read from the stem to the leaf of 1 to 0, 10, 1 to 5, 15, 1 to 9, 9, 1 to 9, 9. And notice how there was no 3s and 30s and 40s on the year 2000. So the nice unique thing about stem and leaf plots is that the data itself is part of the graphic display. So we're seeing all of the original pieces of data as part of our displaying of the data. So why don't you guys try to make a back-to-back stem and leaf plot from this table on voting and didn't vote. Pause the video here, come back, and we'll see how you did. Well, stem and leaf plot does have some limitations. On a stem and leaf plot, we don't have a spot for the age, but we can compare the voting to the didn't vote in a graphic display. So for voted, and if you put voted on the left and didn't vote on the right, that's fine too. You'll just have to reverse it to look at the answers here. But voted for 8 million, that would be 0, 8. 16 is the 1, 6. 24 is 2, 4. 23 is 2, 3. And on the didn't vote, that's where it's going to be read from right to left. So 18 million that didn't vote would be 1, 8. 21 million would be 2, 1. 14 would be 1, 4. So we have the limitations that we can really only compare at most 2 sets of data, or 2 different variables with our set of data with vote and didn't vote, and there was not a place to put our age discrepancies. But there was a place to look at how many millions have voted and didn't vote. So overall, there are some great parts about stem and leaf, and there are some limitations about stem and leaf. The biggest plus, or the biggest pro for stem and leaf plots, is that a stem and leaf plot has the benefit that all of the data points values are also available for analysis. So we can still see all the original data as part of the graph. If we were doing a histogram and we put everything into bins, then we don't really see all the original pieces of data. So that is a benefit of stem and leaf plot, that we can see all the original pieces of data, and then we could do further analysis. We could answer different questions because we could still see all the original pieces of data. One of the big disadvantages, besides grouping them in other ways, is that it doesn't work really good for large sets of data. So the disadvantage, however, is that the stem and leaf plots are very difficult to manage for large data sets. So I hope that helps you guys get started on using stem and leaf plots. And I hope you guys have a great day. OUT spells out.